Power functions with negative integer exponent, exercise 1, parts B and D. So I will work out only these two parts, and the rest of those is assigned as homework for you. Okay, so let's start with part B. So we should use the properties of power functions y equals x to the power of negative n to compare the following two numbers. So we have the first number of minus 2.3 to the power of negative 3, and we have to compare it with the number 2.3 to the power of negative 3. So both these two values are the values of a function. We can think about it like y equals x to the power of negative 3, or 1 over x to the power of 3, which is the same. Well, this function has the graph, which we may sketch here. Sorry about the crudeness of it, but I'm not able to draw lines very well here. So this is the origin, this is y coordinates, x coordinates, and the graph should pass through this point with coordinates 1 and 1, and this one with coordinates minus 1 and minus 1. Since negative, the power is odd, and it should have two branches like this. Okay, so this should be the graph of the function y equals x to the power of negative 3. And now one of the numbers that we have to take as values of x is x1 equals minus 2.3 and x2 equals 2.3. So x1 is perhaps somewhere here and x2 is somewhere here. Okay, but now we have to compare the values. So this value f of x1 and this value here f of x2. So this is f of x1 and this one is f of x2. Now, since the function has some sort of symmetry, and we know its symmetry with respect to the origin, the function of this form is odd. And for any odd function, we know that f of negative x equals minus f of x. Okay, so if we know this fact, then we may simply state that this number here, f of x1, is the same in absolute value as this number here, f of x2, but they are opposite numbers. So we may say that this number here is for sure negative and is less than this number, which is positive. So this answers this part of the exercise. But moreover, what we can say is the following. We may say that minus 2.3 to the power of negative 3 is equal to minus 2.3 to the power of negative 3. This is something we can say even, this is more than we were asked to say. Okay, so we deal with more than we were asked. Now in part D, we have a somewhat different situation. We have to compare two numbers, minus 4.8 to the power of negative 4 and 4.9 to the power of negative 4. So these are both function values of a function y equals x to the power of negative 4, or you may imagine 1 over x to the power of 4. It's the same. This function has an even exponent. The exponent of this function is even. So if I sketch its graph, I know something about it from the prior theory. So this is the y-axis, x-axis. The graph of this function, since n is even, should pass through this point with coordinates 1, 1, and this point here with coordinates minus 1. Sorry, no, this one. Sorry, this point here with coordinates minus 1 and plus 1. The graph of such function should have two branches, and they would, or they should look similar to what I draw now. So these are the branches of the function y equals x to the power of negative 4. Now we have two numbers, two x values, x sub 1 equals minus 4.8 and x sub 2 equal to 4.9. So x sub 1 is somewhere here, x sub 1, and x sub 2 is somewhere here. Okay, the function value of this is here. So this is f of x1, and f of x2 appears here. Okay. Now, I don't know whether this is precise enough to make any conclusions. So wait here. Don't say anything before we can be sure about it. Okay. So now this function definitely is even. So if the function y equals x to the power of minus 4 is even, it means that f of minus x equals f of x. And we can use this. We can use this to our advantage, and we can use it as follows. We can say that minus 4.8 to the power of negative 4 must be the same as 4.8 to the power of negative 4. And so instead of comparing these two values, we will now try to compare the value of 4.8 to the power of negative 4 and 4.9 to the power of negative 4. So 4.8 is here. Well, let me draw it again. I will just wipe this off this screen and say 4.8 is a number which appears somewhere here, 4.8, and 4.9 is a number which appears here. Okay, and since the function, as you may know, is decreasing in this quadrant, you may state or assert with certainty that this function value for the value of 4.8 is greater than this function value because the function is decreasing. So here I get more than here. Okay, so therefore this is true, but since this number is equal to this number, it makes it possible now for me to add this sign here and to conclude that minus 4.8 to the power of negative 4 is greater than 4.9 to the power of positive 4. And here we are. This is the final answer to this exercise.